Have you ever sat on a plane, waiting for takeoff, and just wondered about all the incredibly complex stuff happening to get you in the air? Well, today we're going to pull back the curtain on one of the most critical, yet totally invisible powerhouses on every single modern jet. And it all starts with a few pretty big questions.
So first off, just think about the size of this problem. You can't just turn a key on an engine that weighs as much as 3 big pickup trucks. I mean, you need a massive amount of force just to get those giant fan blades to start spinning. So, how do they do it?
And then think about where you're flying. Up at cruising altitude, the air is incredibly thin and, frankly, lethally cold. We're talking minus 50 degrees Fahrenheit. Yet inside the cabin, you're perfectly comfortable, breathing easy. So where does all that nice, warm, pressurized air come from?
And, maybe most important of all, let's talk about safety. When you're flying through clouds up there, you're in an environment where ice can literally form on the wings in seconds. That's bad news because it messes with airflow and lift. So what's the invisible shield that protects the plane from that constant threat?
Well, believe it or not, the answer to all of those questions is exactly the same. It's one single, elegant, and really powerful system. It basically acts like a second invisible engine, using super hot, high-pressure air to do some of the most important jobs on the aircraft. It's called the Pneumatic System.
Okay, so if this thing is so powerful, where does it get its energy? You might think there's some kind of extra engine tucked away somewhere, but the genius of it is that it doesn't need its own fuel. Instead, it cleverly taps right into the heart of the jet engine itself.
And the key term you gotta know here is bleed air. Now, it's not a leak like the name kind of implies. It's air that's intentionally and very precisely siphoned off or bled from the compressor part of the main engines. This is air that's already been squeezed and heated up by the engine, which makes it an incredibly potent source of power.
And the system is really versatile. While the main engines are the go-to source for bleed air during the flight, the whole system can also be powered by the APU. You know that smaller jet engine in the tail of the plane? That's what they use on the ground. And when the plane's just sitting at the gate, they can even hook it up to a high-pressure cart right there on the tarmac.
Now, this is where it gets really clever. The engines actually have 2 different spots, or taps, to get the bleed air from. During cruise, when the engines are humming along at high power, the system just sips air from the low-pressure port. That's plenty. But say when the plane starts to descend and the pilots pull the power back, the system automatically and seamlessly switches over to the high-pressure port. It does this to make sure the pneumatic system always has enough juice to do its job. It's this smart switching that makes the whole thing so efficient because it only ever borrows the absolute minimum energy it needs from the engines.
So, okay, having all this raw power is one thing, right? But figuring out how to control and direct all of that insanely hot, high-pressure air, well, that's a whole other challenge. And it requires a pretty sophisticated combination of brains and brawn.
The brains of the whole operation is the Air Management System Controller, or AMS for short. This is basically a computer that's the central command for everything. It's constantly reading sensors and opening and closing valves, managing the pressure, temperature, and flow of that bleed air with incredible precision. It's always working.
And the brawn? You can think of that as the system's arteries. It's this whole complex web of specialized insulated metal ducts and flexible joints that snake all through the plane, carrying this super hot air from the engines out through the wings and the body to exactly where it's needed.
But before that air can be used for most things, it has to be cooled down. A lot. I mean, remember, it's coming straight out of the hottest part of the engine. That's where this thing called the precooler comes in. It works almost exactly like the radiator in your car, using the freezing cold air from the engine's main fan to bring the temperature of the bleed air way, way down.
And this really shows you just how hot we're talking. Even after it's been cooled down by the precooler, the air flowing through those ducts is still at a baseline temperature of 204 degrees Celsius. That's 400 degrees Fahrenheit, hot enough to cook with, easily.
Now, to manage all this airflow between the left side of the aircraft and the right side, the whole system relies on one single vital component. You could call it the gatekeeper, the cross-bleed valve.
This valve has 3 really important jobs. Most of the time it's closed, keeping the left and right engine systems totally separate. That's step 1. Isolate. But it can open up to connect the 2 sides. This lets a single source, like the APU or just one of the engines, power the entire pneumatic system. And that leads to its 3rd and most critical function, enable. It's absolutely essential for starting the engines. All right, so now we've got this controlled network of incredibly hot, high-pressure air ready to go. So what do we actually do with it? Well, this is the good part. This is where the pneumatic system performs its three most critical jobs.
I mean, check this out. This one single system handles three completely different but equally vital jobs. It starts the engines, it provides the very air you breathe in the cabin, and it protects the plane from dangerous ice. It's really an incredible piece of engineering.
Let's go back to that first question we asked. To start those giant main engines, high-pressure bleed air from the little APU in the tail is basically blasted into the engine starter. That starter is like a tiny air-powered turbine, and this gust of air spins the main engine component so fast that when fuel is finally sprayed in, bam, you get ignition, and the engine roars to life.
Okay, job number 2, air conditioning. That same bleed air gets sent to these things called air cycle machines. It's in there that the air gets cooled down even more, filtered, and the humidity is adjusted perfectly before it's gently pumped into the cabin. That's the fresh air you're breathing. And it's this constant flow of air that also keeps the cabin pressurized to a safe and comfortable altitude.
And finally, we have what is maybe its most demanding and most critical safety job, anti-icing. For this task, the system needs the air to be as hot as it can possibly get. So it's channeled through special ducts right to the front edges of the wings and the engine inlets.
And how hot are we talking? Well, when the anti-ice system is turned on, the AMS controller lets the bleed air temperature climb all the way to 231 degrees Celsius. That's almost 450 degrees Fahrenheit. That is hotter than most ovens in your kitchen. This extreme heat makes it impossible for ice to build up, ensuring the plane can fly safely no matter the weather.
So when you put it all together, you realize this system is so much more than just a bunch of pipes and valves. It really is the unsung hero of every single flight, a truly elegant and deeply integrated piece of engineering.
So why does this matter? Well, because the pneumatic system is a masterpiece of efficiency. It takes what is basically waste energy from the engines and turns it into functions that make modern air travel even possible. It starts the engines, it lets us breathe at 35,000 feet, and it provides this critical layer of safety against icing. It's a hero, hidden in plain sight. So, the next time you're sitting at the gate and you hear that gentle hiss of air coming from the vents, you'll know exactly what it is. It's the sound of the pneumatic system, that invisible engine, hard at work getting ready for the flight. And it might just make you wonder, what other incredible, hidden systems are out there, quietly making the impossible possible?